All right, looks like we've given a few minutes, and we might have some late folks join, but we'll get started. Good afternoon, everybody, and for those attending from the West Coast, good morning. My name is Paul Lefebvre, and I'm a business development executive here with MBSI WAV, and excited today to introduce one of our partners, Positron Access Solutions, to our webinar today. Joining us from Positron is Jim Staheli, who is Senior Vice President of Sales. Jim will be giving us a review of the key elements of the Positron solution offering, with emphasis on how service providers, operators can deliver symmetrical gigabit bandwidth to applications using copper pairs and coax in pre-wired buildings without having the need to extend fiber or any additional wireless services. Since MBSI WAV has partnered with Positron, we have seen great interest from our service provider and our partner community, and the timing of this webinar couldn't be better. If you have any questions as Jim's moving through his slides, feel free to put them in the chat window below. I'll collect them, and once Jim is done, we'll have a little Q&A session. I'm sure there will be some questions out there. Keep in mind that here at MBSI WAV, we can help with any type of pre and post sale support, network engineering, and as it relates to the material today, any type of business case analysis for these types of solutions that you may be considering. With that being said, I'll turn the floor over to Jim to move through his presentation. Take it away, Jim.
Thanks, Paul, and welcome everyone. Again, I'm Jim. I'm from Positron. You may have known me previously from Airspan Mimosa, and before that, many years at Calix. So I spent a lot of time in the broadband, wireless, and wireline community. Wanted to note you're going to see my eyes look up to the screen above because I have multiple screens and the camera's down below. So I am, if that looks funny to you, it's because I'm looking up at the screen where the presentation lies. In the presentation today, we will talk about, as Paul mentioned, how to get the most out of existing inside wiring and avoid the cost of rewiring. We do business here at Positron in many countries, and they're all different with respect to who owns what facilities and so forth. In Canada, you'll have to give me some guidance as we go through about how you get access to inside wiring inside these garden style, mid-rise, high-rise apartments, and other sorts of buildings with inside wiring where our product makes a lot of sense if you can get access to that wiring. Again, as Paul mentioned, ask questions as we go. Here's what the presentation agenda looks like. I've got some key takeaways, which I'll talk about at the beginning and then at the very end of the presentation. I've got an overview of who the company is. We're a Canadian company. It's my first time working for a Canadian company based in Montreal. We'll talk a little bit about what the technology is, the standard G.9660, G.hn. We'll talk about the market segments and the different applications for the product that we have found remarkably to provide a huge global segment of business for us. And then we'll talk about the portfolio, the equipment, which you can get from MBSI WAV. We'll have some application examples, and then we'll take questions, but feel free to chat questions anytime during the presentation. The key takeaways, what I want you to leave with is that a new generation of ISPs are trying to get in there and serve all sorts of customers with better bandwidth than the incumbent providers, both cable companies and telcos have been doing of late. We often talk about the digital divide here in the US, and I'm sure that's the case in Canada as well. And most of the digital divide monies are focused on the rural customers. But in fact, there are many multi-dwelling units that the carriers have just passed by or not provided significant competition within or significant bandwidth, enough bandwidth, adequate bandwidth while people are suffering with COVID and have to work from home and do school from home. So there's a missing element in the digital divide, and that is in multi-dwelling units, be it in suburbia, more rural environments, or in the center of a city, business or residential. The G.hn solution, particularly our G.hn access multiplexer, the GAM, significantly beats other coaxial and copper broadband technologies like DSL or G.fast or DOCSIS. And then we match performance to current fiber to the door technology. So if you can do active fiber or PON and you've got fiber in the building, by all means, inside that building to the door, go do it. But if you have to rewire a building with that fiber, we recommend a different solution. Just connect that fiber, extend that fiber with our GAM. Our design convincingly also is superior to other G.hn solutions, which are typically OEM from China, silk screen the box, don't have much control over software or hardware. We have spent many man-months in Canada designing a system with software that we can control, with vector boost, with provisioning, maintenance, security, and diagnostics that you can use in carrier class applications to provide service level agreements and business Ethernet type solutions. The total cost of ownership of our solution, the key to it, is it's always going to be superior to rewiring with fiber or copper. By all means, if you got fiber or copper inside the building, or Cat5 or Cat6, you have a solution that you can use, go for it. But even if Cat5 and Cat6 are there, our solution will take it much further. As I mentioned, Positron's a Canadian company, established in the 1970s, and doing business proudly since with telcos and energy companies, utilities, with lots of energy and access solutions. So the GAM is simply the newest product in our stable. It's just a very, very exciting one. For those of you who are not as familiar with G.hn, that's what this slide talks about. Again, it's a standards-based G.9660. It's evolved somewhat like PON. PON went from proprietary solutions to BPON to GPON to next-gen PON, XGS PON, and so forth. G.hn has gone through its own evolution, also quite positive, to a standards-based solution, and then finally to a more hardened solution called Wave 2 that provides 2 gigabits per port that can be utilized for any subscribers. The next generation Wave 3 will be out in 2023, and that's 5 gigabits on copper twisted pair and 10 gigabits on coax. Our solution in particular leverages a non-blocking Ethernet core to efficiently distribute multi-gigabit bandwidth throughout all of our ports. Typically, when one sees oversubscription, it's going to be back on the transport link. We make sure to make ours as non-blocking as possible. We also do real-time upstream, downstream control of the performance of the circuits with our technology. We'll talk about that a little bit more when we get into applications. And then, of course, the time savings, the mess savings, the cost savings, using the existing coax, if you can get access to it, using the existing Cat3, if you can get access to it, is much more effective than putting new wiring inside the building through steel and concrete, or just drywall for that matter. So where does G.hn and particularly the GAM fit in its table of cost effectiveness and future proofness? This chart shows that where a technology wants to be is up and to the right. Up and to the right means it's more cost effective and more future proof. Other technologies like G.fast, DSL, and DOCSIS are both lower on the chart in terms of future proofness because they're not all that future proof anymore, and they're not very cost effective either. When newer DOCSIS comes out, I'm sure it's going to provide some better symmetricality, better symmetrical services on coax, but it's not really here yet, and it's also very expensive. With respect to Ethernet and optical, they're great if you got them, but if you don't and you have to rewire, we're just as capable, and we don't require the rewiring, so that's why we're equal to them in terms of future-proofness and much better in terms of cost effectiveness. Then fixed wireless access is all over the board, right? It's either cheap, maybe unlicensed, low frequency. There's all kinds of cheap options, but they're not very future-proof. Then there's more expensive licensed solutions and high frequency solutions, but they don't go very far through walls, and they are much more expensive. There are some great Wi-Fi inside wiring, inside wireless solutions using Wi-Fi. And what we find ourselves doing very frequently with those solutions is providing their bandwidth to their Wi-Fi access point. Because it's one thing to have a community hotspot inside a building. It's another thing to get the bandwidth to the instant Wi-Fi managed Wi-Fi device. That's one of our strengths. For those of you who need to be convinced, most of you already know that if you can provide a better service to your multi-dwelling unit, multi-tenant unit residents, that you can that it's very important to them. Gigabit is sort of hyperbole, and you can go much lower and still make a customer happy. But Google did it to us. They made gigabit the word of the day, and people who know that they're moving into a place that has gigabit service are going to pay more. They say that that's more important to them than many other things inside a multi-dwelling unit. So the rent can go a little bit higher. The value of the property is higher. And then with our solution, operators can save a lot of money getting to that service level. The rate reach charts are next. This is copper twisted pair. There is an older G.fast is noted there in gray. And then our solution is two lines. It's a blue line and a green line. The blue line is a single pair because we support a single pair of Cat3 24 gauge and can provide up to about 150 meters full gigabit service. The green line represents two pairs because we also support two pairs. That's called MIMO. And two pairs can go into a single port, so you don't have to burn two ports to combine pairs. And then you can provide that same gigabit service much further, up to 250 meters. So that's how copper twisted pair works. And 250 meters, by the way, is 3/4 of the way to the top of the Empire State Building. The coax, being a much better insulator, it also provides much longer reaches, 300 plus meters for RG59, 700 plus meters for RG6, and 1,000 plus meters for RG11. Much better than DOCSIS, and it is absolutely symmetrical. Provide your customers with a rate profile of gigabit up and gigabit down. Obviously, the rate profile can be much less if that's all you need, and that's all the customer is willing to pay. But we want you to know where the stars are represent symmetrical gigabit service. Now, this is a technology that can be used in a lot of different places. So the next few slides talk about that. Garden style, mid-rise, high-rise, pretty straightforward apartments, residential dwellings, and so forth. But don't forget business because of the quality of the service, because we've used MBF compliant components, and some of our tier 1 customers have already tested in their labs. We can offer SLA business services in mixed environments like downtown to high rises and campuses. We also have a big market segment using mostly coaxial facilities. The resorts, they came out of COVID. They were in a bit of a tight situation with respect to finances, but people still want to come to these hotels now that they're free to travel again, as long as we don't have another wave, right? For the moment, people are traveling and the masks are off in most countries. And these resorts are coming out of it saying, we don't really have enough money to remodel and dig into our walls and bring fiber or Cat5, Cat6 to the room. We want to use what we have, including the number of AC outlets on the wall, the electrical outlets, including the existing copper twisted pair of coax. And as I said, mostly coax. They're going in and they're redoing their hotels and resorts with the GAM. Because the technology scales down so well, we have, again, some larger customers who have access to copper twisted pair or coax in the streets, using us as a very effective gigabit service, fiber to the curb solution, as opposed to going into the cul-de-sac and pulling the wires into the home. And if you've got a lot of trees, we can be an alternative to the wireless. You can bring wireless to the neighborhood. And then if you can get access, usually you have the franchise, the market is yours if you have access to either the copper twisted pair or the coax in this situation. But I wanted to mention that we have great fiber to the curb solutions. On this slide, we see the beginnings of the portfolio in some photos here. Coax on the top, copper twisted pair on the bottom. As I mentioned, we support both. Notice that each of the multiplexers has 10 gig SFP interfaces, so very easy to bring whatever bandwidth you have into the GAM using the appropriate non-keyed standards-based SFP plus, and all that bandwidth then can be distributed amongst these ports. And alternatively, we've got a second port where you can take bandwidth in the first port, out the second port, up to the next shelf, and stack it with very low latency to provide very large applications with gigabit service. And I've already mentioned that inside each one of the multiplexers is a non-blocking Ethernet switch. Essentially, the bandwidth comes in, we convert it from whatever comes at us, Ethernet standard, to G.hn. We transport it across through the wires to the endpoint, which is inside the unit, and that converts it back to Ethernet. Copper twisted pair is shown below. These are the ports that accept 1 or 2 pairs in an RJ45 sleeve. You can use an RG11 as well. This is the entire portfolio. You saw the indoor units, indoor rack mount 19-inch, standard environmental, plug them into AC outlets. These are standard solutions over here in 12 and 24 port increments for both copper and coax. And then we have an IP68 hardened unit with 4 or 8 ports, again for coax or copper. So depending upon the application, if you need to put it outside on a wall or inside in an MDF, you've got the solution you need. The endpoints, as I mentioned, the bandwidth comes into the GAMs, comes out as G.hn, goes to the unit, and then in the unit you'll have one of these endpoints. They're about the size of a deck of cards, and in comes the G.hn from the wall plate of your selection, wherever it comes into the apartment unit or business unit, and out comes in comes G.hn, and out comes Ethernet to any Ethernet device, whether it's a Wi-Fi access point, a residential gateway, with Wi-Fi, Ethernet switch, whatever makes sense for the application. We have a unique advantage in that we can daisy chain. I'll show you that. We can hook one GAM up to another GAM in order to get further distances for you. We have reverse power in case you've got situations where you don't have electrical power on site local. So the unit, the endpoint inside the customer's premise can power back and power up the GAM. We've got PoE for those applications. So we can plug in one of the endpoints, and then that endpoint can push PoE out to 802.3 AT and AF devices. And I just saw that some questions are coming through. Do you want to ask that question now, Paul?
Yeah, I guess first question came in is, in looking at sort of the product map here, if there are instances where you're going into a building, an MDU, where both coax and twisted pair exist, is there a GAM that will support that, or is it you have to use 2 different ones? It's
a very good question. A simple answer: you have to use 2 different ones. Here's how you could do it. You could use 2 of the outdoor units, which are smaller, put them side by side, 1 coax, 1 copper twisted pair. Depends on the number of ports you need. You select the GAM. We've got units as small as 4 ports and units as high as 24 ports. With coax, a simple, small 4-port outdoor unit, because we support splitters, could support up to 64 subscribers. That's 16 ports for coax. So you could easily have 1 small coaxial GAM, whether it's plugged in or reverse power, and then you could use a larger one if you need it. Remember, a GAM 12C can support up to 192 subscribers. Now, the coax is naturally arranged that way with splitters. And so the reason we support splitters is to accommodate the natural architecture of any building and how the coax was laid. By the same token, copper twisted pair is going to be a little different, right? Because every copper twisted pair goes from an MDF to a unit, so you're going to need more ports. And in that case, you might need a 12 or a 24 as opposed to a 4 or an 8. But simple answer to the question is you'll need to get one of each. We don't have a mixed port solution because we just haven't seen any demand for that. People typically mix and match. And because you can go daisy chain, even if you have two GAMs, one coax and one copper twisted pair, you can use the SFP ports on the indoor GAM to extend one to an outdoor GAM to another indoor GAM. So it's pretty easy to go in and need only one transport link as well. I hope I answered that question okay.
Yeah, thanks, Jim. We'll any other questions that come in, we'll just we'll stack them at the end. I don't want to derail the momentum of your slide.
No problem. This was a great time for that question since we're looking at the portfolio slide.
Got it.
So now we'll go on to applications, and MBSI WAV will get a copy of this presentation. They'll be able to share that with the rest of the attendees. All the applications look very similar. On the left-hand side, you'll have the data center, the internet, wherever the bandwidth is coming from. And then you'll have the transport going through the middle, and then you'll have a building, and you'll have the GAMs on the right-hand side, or multiple buildings in some cases. Some application notes. The title should tell you a little bit. The application notes will tell you the rest. There's always a legend. All the colors, the lines are standard, and all the icons for the products are standard. So there's like 20 of these slides. We'll go through them pretty quickly because again, you'll be able to revisit them subsequent to the presentation. But here's the standard. Transport blue, could be wireless, could be fiber, could be anything. Comes into an SFP plus port on a GAM. This happens to be the GAM 24M, so that's MIMO, that's copper twisted pair Cat3. This one box can be stacked with other boxes and then come out of one SFP port into the other SFP port, out and in to serve all of them with the same bandwidth that's coming into the first box. That could be 10 gigabit, could be 1 gigabit. We've got a cable modem working in Dalton, Georgia that's only given us 100 megabit, and then we use that to serve everyone in the hotel. So you can see the flexibility there. The yellow lines represent the G.hn extending from each one of the GAMs out to, in this case, up to 96 subscribers. And that G.hn goes to a simple G1001M. That's the endpoint that's about the size of a deck of cards that converts the G.hn back to Ethernet and drops it to residential gateway. You could use the same 1001M to drop it to an Ethernet switch or a Wi-Fi access point for a community hotspot. And we've got some specialty endpoints that have more capabilities, but this one is simply one Ethernet port out, and it's a media converter, trying to keep the cost down. The next slide simply switches the parameters from MIMO, or copper twisted pair, to coax. And with coax, I mentioned we support splitters, so splitters are represented at the building here. A single GAM, 24 ports, can serve up to 384 subscribers. So basically serve an entire building with a single chassis. Bring 10 gigabit, up to 10 gigabit into the GAM again, convert it to G.hn, send it out over the splitters. The GAM manages all the endpoints, whether that's one per port on that 24 ports, or 2 or 4 or 6 or 8 or 16 subscribers per port. Then I wanted to show the solution providing reverse power in case you don't have it. This happens to be a most common application for garden style apartments where there's only one wall and that wall doesn't have any power on it, and you don't want to pay the electrical company to bring power. So instead, turn that first port on with the first MR, that's reverse power endpoint. And that MR is a little bit bigger now. It's about twice the size in length and of the about the same thickness, but about twice the size and length of the regular M endpoint. And it provides reverse power for a single port and the commons associated with that port. And then when you put the second one in, you get the second port, third one, third port, fourth one, fourth port, etc. And this ensures that anybody who unplugs their unit doesn't affect any other subscriber. Coax works identically, except for the provision that because you can use splitters, you really only need one of the CR, which is the reverse power for coax, one of those per port. What some of our customers do is they have in the MDF, what they do is they put 4 of the CRs and power all 4 ports. And then everybody in the building can just use the regular, less expensive G1001C, because you are ensuring that the power stays on and the customer can't unplug it. Or it doesn't matter if they unplug their endpoint, it's just affecting them. In any case, in this particular scenario, we've got up to 64 subscribers served per building with a very small GAM 4 CRX. Now on this slide, let's talk about bandwidth a little bit, because I mentioned that every port is 2 gig. It's actually 1.7 gig after you trim out the overhead and so forth. That 1.7 gig on an a MIMO application means that 1.7 gig is going to each subscriber, because there are no splitters. And that 1.7 gig can be configured in a manner to provide symmetrical upstream and downstream gigabit service in a speed test. So essentially what we do is we dynamically arbitrate upstream versus downstream, so that when the customer is doing, if you give them a rate profile of symmetrical gigabit anyway, if they're doing an upstream test, they're going to get a gig. Then when it flips to downstream, actually it does downstream first usually, flips from downstream to upstream, they'll get a gigabit on their upstream as well, because that's how fast we are. When you're working with coax, you have to keep in mind that you're now sharing 1.7 gig per port with every subscriber on a splitter. So every subscriber on that splitter gets their own endpoint. The endpoints have a rate profile set. The customer's using X amount of bandwidth. So if you give, let's say you got 4 subscribers on an endpoint sharing 1.7 gig, and you give all 4 of them gigabit service, that's 4 gig over 1.7 gig, or 8 gig over 1.7 gig if they're doing dynamic, upstream downstream gigabit. So it's about a 5-to-1 oversubscription ratio. So keep that in mind when you're using splitters, and we'll dynamically arbitrate not only between the upstream and downstream for a single subscriber, but for all the subscribers on that port. As I mentioned, we can do daisy chain. So you can come in with the transport to the first GAM and then use the G.hn ports. In the case of indoor unit, you can use the SFP plus ports to daisy chain to the next GAM. In the case of an outdoor unit, you use the copper twisted pairs underground or aerial between buildings to get bandwidth from the first GAM to the second GAM to the third GAM to the fourth GAM, all the while also serving subscribers. Depending upon how many ports you're using for transport, the rest of the ports can be used for subscribers. And we can do the same thing on coax. So keep that in mind. If you've got access to the coax inside the building and between buildings, you can use that coax to drop an insert to the next coaxial GAM. I mentioned business enterprise solutions. Well, this is one of those business enterprise solutions in use today by a tier 1 carrier with millions of subscribers. And what they've found is that they can't get to businesses fast enough. That is, the coax company, the cable company might be able to get there very quickly, whereas a telco has more difficulty because they have to bring fiber to that building. If they haven't got fiber to that building, it's construction, it's power, it's permits. So what they do instead is use us with a drop and insert to that building. We back power so they don't need AC out in the pedestal, the handhole, and then we provide the service inside the building for them. This is SLA business class service. I mentioned we do PoE, and there are several flavors. See, the endpoint is different. A G2002 can be powered with the same power injector that you saw on the last slide. And that power injector then makes sure that it's got enough power that you don't need to plug it in, and it can provide 802.3 AF out. Now, this is not a 60-watt solution. Notice it's 15.4 standard space for, I think, Wi-Fi 5, right? Category 5. And then we do Wi-Fi 6 as well, and that's 30 watts. But that one has to be plugged in. And then it can extend to the next level. We have had a frequent requests by Siklu and Mimosa and some of the other wireless transport providers to boost the PoE. We're looking into that, but it's not really something we can do through a tiny endpoint. We do RV parks and KOA camps across the United States using coax or copper twisted pair. So I wanted to show that example. When there's trees involved, when I used to work at Mimosa, we used to sell them a lot of radios and get into some high density RF engineering challenges. And you get into the tree situation as well. If they've already got coax, though, you don't even need to get into that situation. The guest will check in. They'll either have their own residential gateway or they'll check one out along with our endpoint. They'll go to their parking space and they will plug it into the coax and they will get their bandwidth. And you can, with coax, the good news is that you can mix higher frequency standard and high definition channels in the mix with our data. Our data runs at 0 to 200 megahertz. Anything above that can be video and we don't see it. But we can provide the internet and then the ride along with the video. Good site surveys necessary. Sometimes there's amplifiers and DOCSIS to get rid of, and there's other things in these networks, but our customers have found it's much cheaper than a wireless, particularly a 5G solution. So those are the applications. If you like, since I'm segueing into software, Paul, do you want to ask a few more questions?
Yeah, no, absolutely. That's great. Good timing on that, because we actually did have another question come through. Actually, I got two here for you. So I guess besides the distance benefits of coax versus twisted pair, if you're running into an environment where both of them are present, is there one that you'd recommend over the other?
If you can get access to the coax and it's pretty good shape, I'd always use that because you've got splitters, so you can support it. The cost per subscriber in US dollars on the MIMO is going to range from 250 to 350 to 400, depending. It depends, right? It's still going to be cheaper than putting fiber into the room, but coax can get much less expensive because you can use a single GAM to serve many more subscribers on splitters. If you need gigabit service, you're not going to use as many splitters, right? But if you and you might prefer using the Cat3 because it's a home run from the MDF to the apartment unit or the business unit. But if you want to make use of those splitters, if you want to save costs, we can get down, as low as 150, less than $200 a subscriber on coax. That might be the winning solution for you. Depends on the speeds you want to offer.
Got it.
All right. So now I want to take a minute to talk about software and subscriber management, because we took the approach at Positron that everybody wants to do something different, and we want to make sure they can do whatever they want. So we have about 6 different ways to get through this. One is a command line interface. So if your techs are comfortable with craft interface and Cisco-like craft interface, that's what you have that, and it's free of charge. Everybody always asks us afterwards whether it costs anything, so I'll go through that as we go. So our standard Ethernet router syntax is free of charge. It goes into every GAM, and you can control every endpoint on that GAM with that Cisco-like Ethernet interface, Ethernet switch interface, and it's free of charge. And I had one more thing to say about it, but I forgot. And there's a web-based graphical user interface as well. Again, single GAM, all the subscribers on that GAM, and free of charge. I'll show you some pictures of it, but it also can be used. Oh, I know what I wanted to mention on Cisco. So you could do all the scripts as well that way, if you like to script your service and do some automation. The graphical user interface does all the diagnostics, provisioning, and everything in a more visual interface. We also are building a what we call VIRTUOSO, Virtualized Optimized Services and Operation system. And that is the one for customers who would like to use our system as an element management system for all their GAMs, usually only applicable to larger customers. And right now it is free of charge as well, but it's read only. So you can see things, but you can't do anything yet. We're building the do it stuff. We're building the write function, and there will be a per subscriber charge for Virtuoso when it's fully ready to sell. In the meantime, you can use it as much as you want free of charge. Just let us know, and it can be loaded into any one of your GAMs, and you can see all of your GAMs. We use it in our own lab for seeing all of our GAMs in the lab and doing demonstrations and so forth. Now, if the service provider has built their own back office already, large or small, we have JSON SNMP available. And so we've provided this to a number of our customers so that they can automate, and their network operations center support team can see everything on a single screen, whatever they'd like to do. So we've got that as well. And then we have a lot of partners, and this is a short list of them. Each day we learn about new ones. And typically how that happens is we have a customer who uses Power Code or CDG or Sonar or ETI, and they say, I need you to be integrated with this. And so we begin work on that. It's usually pretty easy, takes a couple weeks, but we can integrate with just about any of the common platforms out there. We have completed that integration with ETI, RGNets, and Sonar. But anyone that you bring us, it's a pretty simple thing to get it done, because we have JSON and SNMP. So here's some of the commands and scripts for the typical Cisco interface. Here's the diagnostics and configuration and monitoring screens that you would see in the graphical user interface, again, free of charge. Here's how Virtuoso works today as a read-only element management system for multiple GAMs. And then this is how it'll work when it's a charge-based, a fee-based, full element management system next year. This is what Virtuoso looks like. And then if you have questions about partners, just let us know. We're further along with these three, but that doesn't mean we can't do others. We're going to be adding numerous partners to our list this year, I think. Every show we go to, we have another one step up and say, we need to integrate you in our system. So that leads us to the final slide, which is the key takeaways again. Again, I want you to remember that if you're an ISP who wants to meet the needs of today's sophisticated subscribers and compete effectively without rewiring, we're your answer. If you want to beat your competitors using DSL, G.fast, and DOCSIS, we're the answer. If you want to match the price or match the performance of fiber to the door without the cost, the GAM's the answer. And then don't even think about using any other GAM solution, please, or any other G.hn solution, because we have the best. We're built entirely in North America. We have all control over software and hardware, and we're employing Canadians to make sure that you're not importing product from China. That's pretty much it. Now, if there's other questions that came in earlier or via chat, I'll take them.
That's great, Jim. Appreciate that. Great job reviewing the content here. I look at it as, in our customer base up here in Canada, we've got a number of service providers that have, regionally based networks. And this is a great product suite for them to, leverage the network that they've already built in their community and capture, what I would define as, incremental revenue, incremental customers, incremental subscribers. And it's a great tool in the tool chest. You did a great job. So I guess a segue into that statement, I guess a simple question is, if I'm a service provider in an existing footprint and, I see an MDU and, or a business opportunity, what's kind of first step to try to understand if it's, economically viable? What kind of questions should they be asking? Any thoughts on that?
Yeah, that's a great question. So we can help MBSI WAV with this during some calls and so forth. We have tools that allow you to compare one solution against the next, our solution versus anything else, Ethernet or fiber to the prem or somebody else's solution over cable or copper. We've got tools to help you understand that. Very rarely if you have to rewire, does the rewire prove in from a price performance standpoint versus the GAM? The GAM is usually going to win. And I think I'm trying to anticipate where this is headed with respect to another question, and that is, how do you know in Canada is different than the US. In the US, the FCC, this current administration, are really encouraging competition inside the MDUs. So there's a move by service providers to go compete less exclusively. It's now illegal for a cable company to say that they own the coax in perpetuity inside the building, because normally the building owner is the one who paid for that coax and copper twisted pair. So nobody owns it. Even if someone goes in and puts the fiber in themselves, the government's now saying, you don't own that fiber forever. We're going to allow competition, because without competition, the beneficiaries are the landlord and the service provider, usually an incumbent cable provider or a telco. And we want the residents to win, so we want competition. So that's what's going on in the US, which is inspiring, and in some other countries as well, which is inspiring a great deal of effort by CLECs and new generation service providers to get in there and try to win some of that business that they would have just passed by that building before, right? So you folks will have to help me understand better what the rules are in Canada with respect to competition. But from a technology perspective, the GAM is a clear-cut winner whenever you and the landlord are trying to avoid the mess, the cost, the time it takes to rewire.
Do you, just in your experience and, across your customers, is there conversations about revenue sharing models with landlords of properties, MDU owners? Does that come into play at all?
It does. It does, and it has. If you can win the whole thing through some sort of a bid process, there's going to be a time frame associated with whatever contract it is. That's great. We want to help if you win it all, and we want to help if you're going in there and you're trying to compete for each subscriber, pay as you succeed type model, right? In the US, the thing that's happening is that there can be a time-based exclusivity agreement, but there can't be anything in the exclusivity agreement around the facilities inside that building. So that's where things are changing. So it's making telcos and service providers hesitate before putting fiber inside the building when they can already compete with the GAM on existing wiring, and that fiber may or may not be theirs for perpetuity.
That's great. So you mentioned Canada there a few times, and I think we're all aware that a lot of funding mechanisms to connect the underserved, rural broadband programs, a real strong initiative to connect as many homes as possible with gigabit services. Can you just lightly touch on, again, as a residential community, already pre-existing coax, not an MDU, not an MTU, but just a residential community, how your solution can help that, help service providers with that?
You mean in single family homes, or
like a single family homes, residential communities, to that effect?
So what one of the tier ones is doing is they're using, because the goal should be fiber everywhere. I'm a full supporter of that. However, in the meantime, over the next 10, 20, 30 years, while you're trying to do that, gigabit service is going to be adequate. Today, it's more than adequate. The average usage is more like less than 100 meg. That's when somebody's peaking out with multiple high definition channels and gaming and everything going at the same time. 100 meg is still adequate. So gigabit service, what we offer, is going to be adequate for the next 4, 5, 6, 10 years. And what we want our customers to do then is think about the fact that, and our customers are service providers, get fiber wherever you can, and then use us to extend that fiber into buildings. But also, If you can't get to a cluster of subscribers that's too far away from fiber, even if they're in a single family home or duplexes or triplexes, smaller profiles, then use us as a fiber to the curb solution. Bring the fiber to the neighborhood, perhaps. Or if you can't even do that, bring wireless bandwidth to the neighborhood, get it to our GAMs, and our GAMs can take it the rest of the way.
Perfect.
They're very cost effective for 4 or 8 subscribers in a cul-de-sac.
Great. Well, perfect. That pretty well sums it up on the Q&A side. Do you have any last thoughts before I close this down, Jim? Any closing comments?
No, I would just I would invite people to reach out to MBSI WAV. MBSI WAV will get us on the phone if they need additional expertise or technical questions that folks like Paul and I aren't capable of answering. We've got help. We've got site survey tools. So if you've got a building in question, we can help you. MBSI WAV can help you go out there and get that site survey done, because that's pretty important. I went to an apartment complex in Indiana last week. Frankly, it was in pretty bad shape. The coax was lying on the rooftop. Sometimes there were nails that were meant to go through roofing elements that partly went through the sheath of the coax. There was coax lying on the grass where lawnmowers can chink it up. And that's going to be our next application, because we handle those sorts of situations pretty well inside and outside those buildings. But site surveys are necessary to see if there's any amplifiers or anything else running that needs to run, like other video channels and so forth. And we can help with anything you need.
Well, that's fantastic. And to your point, here at MBSI WAV, we're certainly able to support and help as needed as well. So, thanks, Jim. Once again, great overview and information today. I want to thank everybody that joined. We did have some folks join late, so just to recap, this session has been recorded. You'll probably find it on one of our social media platforms in the not too distant future. As always, MBSI WAV will be hosting future webinars. I encourage you to keep an eye on our activity, our social media activity, and you can stay posted on upcoming events that we have. And that does include actually some Canadian-based road shows we're getting in the field, but I'd encourage you to take a look at our website to see some upcoming dates out there. So I want to thank everybody for joining, and wish everybody a great day.
Thanks, everybody. Appreciate your time today.